Hello, this is Dr. Yamada. In this video, I'm going to introduce the concept of post hoc tests. So, what is post hoc test? It is a statistical test that can be conducted after the main analysis, only when the main analysis is an omnibus test, like a ANOVA test, that contains more than three or more groups or conditions. So, if the main analysis you did to test your research hypothesis was independent t-test or paired sample t-test, where you only have two comparisons, then you are not allowed or you don't need to do a post hoc test. And the second condition is the main analysis was statistically significant. So only when ANOVA came out to be significant, you may proceed to do a post hoc test. So it's not either condition. You have to meet both conditions to do a post hoc test. So in this conceptual video, we only focus on the simplest situation where you conducted one-way ANOVA or one-way repeated measure ANOVA. If the main analysis is an omnibus test, it doesn't really tell you which group caused the significance of ANOVA. We don't know which one actually contributed to the significant results of ANOVA. So post-hoc test is really designed to identify which group specifically it was statistically significant. There are many types of post-hoc tests, but in this video, I'm going to introduce only two of them. One is pairwise comparisons with Bonferroni correction of type 1 error, and the other one is Tukey HSD test, honest significant test, starting with pairwise comparisons. So the scenario is a one-way ANOVA. Your main analysis to answer your research question was one-way ANOVA between group A, B, and C. And what pairwise comparisons is nothing but just multiple t-tests. So if the study is a between subject design, and those t-tests must be independent t-tests. If the study design is a within subject design, you must use a paired sample t-test. So if you have watched the previous video that when I introduced the concept of one-way ANOVA, I specifically mentioned you're not supposed to run multiple t-tests. And yes, for your main analysis, you should never do this way because it's going to increase the type 1 error. What post hoc test really is once your research hypothesis is supported, so your main question and main analysis was one-way ANOVA, therefore, you could explore which one was significantly different. A post hoc test is not something you predicted before, right? There's no hypothesis about which group was significant. So that's the big difference between the one-way ANOVA and post hoc test. So to really support your hypothesis, to really say something could be generalized, you have to have a hypothesis. So the post hoc test is just an exploration, not the proof of your hypothesis. Okay? At least that's the logic. And I don't think that's the right way to do it, but as of now, this is what's traditionally done. Even if it's an exploratory analysis, you still want to control the inflation of type 1 error due to multiple t-tests. So Bonferroni correction is really a way to control the inflation of type 1 error. When you test your research hypothesis using the ANOVA, you set an alpha, right? When you conduct a post hoc, you set a separate alpha for each analysis. Okay, so how Bonferroni correction works is you divide the alpha by the number of multiple comparisons. So, for example, let's say in the main analysis, you chose to do a one-way ANOVA and you had three groups, and the test came out to be significant when you set an alpha as 0.05. So, because it was a between subject design, your post hoc test, a pairwise t-test, should be independent t-test, right? And when you have 3 levels, then the all possible pair would be 3. A and B, A and C, and B and C. So what you got to do is you set an alpha, then what you have to do is you just divide by 3, which gives you 0.01667. So this alpha is the new adjusted alpha. So after you obtain the p-value of the t-test, you say this pair is significant only when the p-value is less than this new adjusted alpha, even though you originally set 0.05. So let's go through some examples. And just for clarification, all the numbers I introduced are complete hypothetical numbers. I didn't run any stats or I didn't make any calculations, okay? So imagine that the main analysis one-way ANOVA between 3 groups, and it was significant. The group mean was 16 for group A, 10 for group B, and 12.5 for group C. Before you do a pairwise comparison, you set an alpha. So after you run the multiple independent t-tests, the p-value you obtained from each t-test was these numbers. So although you originally set the alpha as 0.05, after the correction, it was 0.01667. So this indicates the only p-value that was less than this number is between A and B. So you conclude that there was a significant difference between group A and B, but there's no difference between A and C or B and C. Basically, what caused the significance in one-way ANOVA was the difference between A and B. So just to give you one more example, so in the exact same study design, let's say the group means you obtained were like this. So the numbers are completely different between each other. And after you run the pairwise t-test, you obtained those p-values for each t-test. And then after Bonferroni correction, the alpha was 0.01667. So in this case, all the p-values are less than the adjusted alpha. Therefore, all pairs are significant with each other. So last message about the Bonferroni correction is Bonferroni correction is just a way to control the inflation of type 1 error, and all other post hoc tests you can learn are different ways to control the inflation of type 1 error. And Bonferroni correction, pairwise comparison with Bonferroni correction, and has been criticized as too conservative. So the next one I'm going to introduce is Tukey HSD. So I'm just going to explain the conceptual aspect. So what you have to do is first you calculate the absolute mean difference among all pairs. So using the same example, and when you calculate the mean difference, then you would get 6, 2.5, and 3.5. Then when you run Tukey HSD test, eventually what you obtain is called HSD score. Then you compare this HSD score versus each absolute mean difference. If the mean difference is greater than the HSD score, that pair is statistically different. Something else you have to be careful when using Tukey HSD is that this test is parametric statistics. So the data must meet the normality assumptions, and it's accurate only for equal sample size between groups. Another assumption is data is independent. So it works only for post hoc after one-way ANOVA, not one-way repeated measure ANOVA. One thing I can tell you is that you should never do many different post hoc tests and just pick the results that you want. Instead, what you must do is you should declare which post hoc test you will use before an experiment, and then just follow through with what you said.